So today I'm gonna start a new series where we will go for 100 question on 100 interview question on 100 days on data engineering. So first we will go on that what is the main difference between repartition and Coolidge. So I faced multiple interview and as a data engineer on that this question is the most common question they have asked. As a beginner level, you can give one liner of answers, but as you have experience, if you're an experienced person, only one liner answer will not be sufficient. So today I will explain you what is the main difference between repartition and coalesce. So if in interview, if you in future, if you will face any interview at experience level, so you can give that answer better. So first we will understand what is that partition. So whenever we submit any job, so Spark is doing the parallel processing. So every time whenever we are doing the processing, each task we will call as a one partition. So suppose when we submit the any task and it will convert that task into multiple partition. So one task will be like one partition. So what is happening? So whenever we will give the poor partition, it will give that it will give the issue that we are seeing CQ. So we will understand in the coming slides what is the CQ and how we can resolve that issue. So first we will go through what is the repartition. So, so repartition and coalesce in that both we can do that. We are manipulating the partition only, but whenever we are using the repartition, we can increase or decrease the partition number of partitions basically. So whenever we want to like we have that scenario where we want to shuffle the complete data and we want to reorganize that partition. On that scenario, we will use a repartition. So whenever we will use a repartition, it will shuffle all the partition and it will distribute all the data evenly in each partition. So what is happening whenever we have like large volume of data and we have applied the partition. So mm, we- we applied any transformation like some filter operation we have applied, and suppose some you have some country, based on that country you want to get some number of person name. So how it so based on US, if you pick some data, so what will happen in every partition, it will give the data after filtration, like the partition number of size of data will be different. So suppose in P1 partition 6 GB, P2 partition 3 GB, P3 partition 1 GB. So each partition have now the similar size, but the data size will be different. So so this is we are seeing the CQ issue. So to CQ issue, we want to resolve that. We will use a repartition. So what repartition will do? Whatever the partition we have given, so it will revalidate all the partition. It will shuffle all the data and it will distribute the data in each and every partition equally. So, suppose we have applied 10 partition. So in every partition, it will divide the 1 GB of data. So data can process evenly and it will not give any issue while joining or like while doing that any transformation part. So data CQ after filter before joins or aggregation. When we are using repartition, data CQ after filter. So, yeah, as I mentioned, we have some filter operation, and after that, we got uneven data in each partition. So, what it will do, it will redistribute the data, reshuffle the data, and it will evenly distribute the data in each partition. Before joins or aggregation, because we have multiple partition, and while joining, if we will do that partition like uneven partition, will on top of that, if we will perform the partition, what will happen? Few records will join immediately, few will take time. So to come off of this issue, we will use the repartition. And whenever we need balanced parallelism, then we will use a repartition. Now we'll come on that Coalesce part. So if we only have to reduce the number of partition on that scenario, we will use Coalesce. So Coalesce will not suffer completely. So whatever data we have, it will only merge it, and it will be very cheap operation. So how it will work? So suppose we have 200 partition of 20 to 25 MB data. So we have applied some filtration, and now the data size will get reduced. So what will happen? Um, we will just reduce the number of partition, and after that it will 10 files. So 500 MB of data will distribute on each of the partition. With, when we use Coalesce before writing into the output data. So suppose we have multiple partition written, and whenever you are writing in some delta location or some output location, so before writing that, we can use a Coalesce. So it will save that file in whatever number of partition we want. It will save on that particular partition only. To avoid so many small files, we can use Coalesce. When data is already got processed, then on that scenario you can use Coalesce. So in high level, we will see repartition versus Coalesce. So repartition, shuffling, yes. Balancing, yes. Costly, yes. It's a costly process because mostly we are shuffling the data and we use the executor and code on that. So that's why it's becoming costly. Coalesce, shuffling, no. We are not doing any kind of shuffle. Balancing, no. Cheap, yes. It's a cheap operation. So if I will say in one line, I use repartition to rebalance secure data before heavy processing, and Coalesce to efficiently reduce partition before writing output. So this is overall about that repartition and Coalesce. If you have any question, feel free to comment. I will try to help you out on that query. Thank you.